Alright, in this tutorial right here, I'm going to show you how to use synthetic division on problems. Number 1, x cubed plus ax squared plus 11 minus 20, and it's divided by x minus 1. So the first thing I'm going to do here is I'm going to ask myself, well, when I divide x, or this function by x, what would happen? So what's going to happen when I do synthetic division, all of these exponents are going to reduce by 1. The next thing I'm going to do here is I'm going to see this parentheses right here, and I'm going to set that equal to 0. This one. So x is equal to 1. Now what I'm going to do is I'm going to write out a table. So I'm going to put the 1, which I got solved for, and I'm going to draw a table of all the numbers in front of the variables. So it's going to be 1, because it's 1x cubed, 8, 11, and negative 20. Next, what I'm going to do here is I'm going to drop the 1 from this side right here. Then I'm going to say, well, 1 times 1 is 1. So, what I'm going to do then is I'm going to add 8 and 1, which I'm going to get 9. 9 times 1, which is going to be 9. 9 plus 11 is going to be 20. 20 times 1 is going to be positive 20. Negative 20 plus positive 20 is just going to be 0. So, okay, so I got that so far. So what's going to happen, what happens when I have a 0 remainder? That means, when I have a 0 remainder, that means I have a perfectly factorable equation, or factor. So what's going to happen is, like I said, because I'm dividing, that means I'm going to reduce the exponents by 1, because I'm dividing it by x, right? So the new factor I got is x squared plus 9x plus 20. So that's going to be the new factor I get. That's how you use synthetic division. So remember, when you have a 0 remainder right here as the final, that means you have a perfectly factorable expression. Suppose you get a problem that looks like this. 3x cubed plus 4x squared plus 5x minus x divided by x minus 2. So the first thing I'm going to do here is I'm going to get what's inside this parentheses and set equal to 0. X minus 2 equal to 0. X is going to equal 2. Alright, so I'm going to draw that right here. And then what I'm going to do is I'm going to draw the table. Alright, so then what I'm going to do is I'm going to put the appropriate variables or numbers in front of the variables in the table. So I got 3, which is the leading coefficient from the x cubed. I got a 4 in front of the x squared, 5. And I got a negative 6. Alright, so what's going to happen is I'm going to drop down this 3. And it's going to go right here. And then I'm going to ask, well, it's going to be 2 times 3, right? 2 times 3 is 6. I'm going to put 6 right here. Then it's going to be 4 plus 6, which is 10. So it's going to be 2 times 10, which is 20. 5 times 20 is 25. Or 5 plus 20 is 25. Excuse me. Because you're multiplying, adding, multiplying, adding, multiplying, adding. And then 2 times 25 is going to be 50. 50 minus 6 is going to be 44. Alright, so notice how I don't have a 0 remainder there. So that means this is not perfectly factorable. So what I'm going to do here is I'm going to rewrite everything right here, but I'm reducing it by the fraction, where I'm reducing it by the exponent. So this is going to be 3x squared plus 10x plus 25 plus, and it's going to be 44 divided by x minus 2. And the reason why I got 44 over x minus 2 is because that's the number I'm trying to get, that it's not because it's not perfectly factorable. So that means I'll just put the number I got as the remainder and divide it by what I try to divide the whole thing by. So that's the final answer. Alright, try this one. X cubed plus 6x plus 4 divided by x plus 3. Alright, so what I'm going to do here is I'm going to first set this, what's inside this parentheses, equal to 0. So x plus 3 is equal to 0. X is going to equal negative 3. But notice this. Notice how it goes from x cubed to just 6x. There's something missing here. What we need to do when you have a missing variable in descending order is you want to put a 0x or a 0x squared in this example. So it's going to be x cubed plus 0x squared plus 6x plus 4. So you want to make sure you write this in descending order properly. So when there's no variable, let's say that you have a function, it's like, well, x cubed plus 5. So, like, what you want to do here is you want to write x cubed plus 0x squared plus 0x plus 5. And you want to make sure you write it just like that. Alright, so that doesn't apply to this. So what I'm going to do here is I'm going to now get the appropriate variables in front, or the numbers in front of the variables. Alright, so I got a negative 3, and I'm going to draw out the table, which I solved for negative 3. And it's going to be 1, it's going to be 0, 6, and then 4. Alright, so now what I'm going to do is I'm going to simply drop the 1 right here. 1 times negative 3, I get negative 3. 0 minus 3 is going to be negative 3. Negative 3 times negative 3 is going to be 9. 6 plus 9 is going to be 15. 15 times negative 3 is going to be negative 45. Negative 45 plus 4 is going to be negative 41. Alright, so what I got now is I got a negative 41 is my remainder. It is a non-zero remainder. So what that means is I'm going to have to do this, I'm going to have to reduce all of these numbers by their exponents. So initially it was x cubed, but it's going to be x squared now. So it's going to be x squared minus 3x plus 15 minus 41 divided by x plus 3. And that's going to be my final answer for this problem.